Cool. So, hi guys, this is Chris from Hacks. Welcome to join the second ZetaChain Omna Hackathon workshop. And today we are very happy to have Dennis, who is the head of the developer experience from ZetaChain, to join us as the today's workshop speaker. So a little bit background, like the whole picture of this hackathon. So this is actually the very first time that Hacks to support the action through the online hackathon. And the hackathon have already started the submission channels from since last week, and it will last for 45 days till the end of the June. And we have around 6 tracks and 50,000 prize pool for developers to join and compete. I would say it's a very great chance because through this hackathon, basically some of the best teams can not only win some prizes, but also can connect with the ZChain teams directly, and potentially these teams will have more supported and connected with more resources, including the ZChain grants program in the future, basically which can help to bootstrap the early stage growth of these early stage projects. So I would definitely see that as a chance to join a hackathon because you will get some of the best support from both ZChain teams and Drawhacks team at the same time. So for today's workshop, Dennis will give a speech about developer introduction. Dennis, feel free to start when you feel it's ready. Feel free to start to share the screen.
Thank you, Chris, and welcome everyone to the second part of the workshop on how to build Omnichain contracts and how to use message passing with ZetaChain. So in today's workshop, we're going to cover different topics. So instead of building a single project, we're kind of go through different features and look into a few projects. So let's begin. First, if you go to ZetaChain GitHub, you will see an example contracts repo. This repo contains the source code for the projects that we have in our tutorials. Right now we have 3 projects: Hello World, Withdraw, and Swap. All of them, well, the Swap and Withdraw are Omnichain contract tutorials. Hello is just Hello World. And yeah, last time, let's open this project in an editor. So last time I showed that all the example projects have helpful tasks that let you create an account, query for balances, and use the faucet. This is very handy. If you're starting from scratch, you can also go to the template repo and fork that. It includes all the tasks, so you don't have to code it from scratch. You can just reuse the template. So since then, we've added more functionality, specifically the verify task, and I'm going to show it right now because this is very helpful for debugging purposes and just generally a good idea to verify your contracts. Of course, with Hardhat, you can verify contracts using the Hardhat verify command, but for ZetaChain, the process is slightly different. So we now have a verify Zeta task. So if you go to the Hello World project, for example, you can, I mean, it's a very simple contract, barely does anything, but it's a good example of how to verify. So if you run npx hardhat deploy and specify that we want to deploy to the current ZetaChain testnet, which is called Athens, I already have an account in my .env. If you don't, then use npx hardhat account /save and query the faucet. I already done that. So we have a contract deployed, and if we go to the Explorer, we will see that it has been deployed, but it doesn't have, you can't interact with it, and it's harder to debug a contract like this. So what you can do is you can verify the contract on the web, right? So it takes a while for a contract to actually show up with this UI, just because it's indexed slower than it's published on chain. But you can verify the contract with this UI on the web. Click verify and publish, and it expects to get metadata JSON. So you can find metadata in the build info. So this file, if you find this file and drop it here, verify and publish. So now it has been verified. You can see all the data, you can copy the code. If there's more than one contract, you can browse through them. But what's more importantly, you can interact with it. So this is a very simple contract, but it still has a function called flow zeta, which returns just a string. So if you click that, you will see hello zeta. So this is very useful for querying the contract without a terminal. You can just browse, click a button, and get the value. And you can also write to the contract if you have MetaMask installed. So you can also do the same on the CLI, which some might find easier. So let's deploy again the same contract. We just deployed it again, and now we can use npx hard hat verify data and pass the contract. So it asks you to choose the contract because your project may have more than one contract. Right now we just have one, so you just press enter, and it verified the contract on the CLI. So sometimes it's easier to just do it on the CLI. You can do this on the web as well. So if you go to this address, you can see that it's also verified. Okay, so that was just a tip, helpful utility for you to verify your contracts. Now I want to go into the swap tutorial. We're not going to code it from scratch because it would have taken much more time than we have, but we'll go through this contract and see how it works. So if you're interested, you can go to the docs and go to the tutorial section. There is a swap tutorial here, so you can follow along in the docs. All the tutorials start from the same template, so it's very easy to follow along. But what we're going to do is look how you can implement cross-chain swap functionality very easily with the Zeta chain. So as we seen in the past workshop with the withdraw tutorial, let's put them side by side to compare. So the withdraw tutorial, we implemented on cross-chain call. This is the only function you need to implement for a contract to be considered Omnichain contract. And in the withdraw tutorial, all it did is basically withdrew the same tokens that you put in to the same address or to a different recipient address. So just a good demonstration on how to implement the most basic cross-chain contract. With swap, it's kind of similar. You also need to implement on cross-chain call because that's the command, that's the function that will be called when a user sends tokens to a TSS address. So every chain connected to Zeta chain has a special TSS address, which is just a regular address that users can send tokens to. And the value of this transaction may contain an address of a contract on Zeta chain that will be called, and the payload. And the address is the address of the Omnichain contract you have on the Zeta chain, and the payload is the message that on cross-chain call gets called with. So in our withdraw tutorial, we just had recipient. In the swap tutorial, we have more arguments. So we have an address to send tokens to. We have an address of the ZRC token that we want to send, recipient address and minimum amount. So what this function does under the hood is it uses a helper. We can see it here. So put it side by side. So in swap helper, we have a function called doSwap, which actually does the heavy lifting. And we're passing a bunch of arguments to this function. So the first one is system contract WZeta contract address and Uniswap v2 address, both factory and router. So what is system contract? System contract is a contract deployed on Zeta chain that contains useful information about the environment, and it helps your contract, such as swap contract, to get the necessary values. So to use system contract, you can import it using this import statement from ZVM protocol contracts. And you can find its address in the documentation. So if you go to zetachain.com/docs, under reference, there is a testnet page, and this page contains useful addresses. So system contract as well as TSS addresses on all the connected chains and connector addresses, which you will need for message passing, and also Zeta token contracts on all connected chains. So system contract is only deployed on Zeta chain, so we can find its address here. And if you click on it, you can see the familiar Zetascan Explorer UI. And of course, it's verified contracts. That's why I showed verification in the very beginning, because it's useful to actually get the values, right? So you can call this contract from your smart contract and get the values that you will need to pass to your functions, but you can also query it here. So fungible module address can get gas coin ZRC by chain ID. So let's say BSC testnet is 97, I think. So we get the address. So this is useful. And you can write, but it's less useful with the system contract. So, okay, so we covered the first 3 arguments, and then you just pass all the arguments that you sent as a payload. So a user sends tokens to the TSS address on BSC testnet, and the payload is this. Okay, so what does doSwap does, right? So it first checks if a pool like this exists, and we're not in this contract, in this tutorial, we're not implementing the swap functionality, right? We're not implementing an AMM. We're using an existing Uniswap AMM deployed on Zeta chain. So this contract just facilitates the cross-chain token transfers and swaps tokens on Zeta chain. Currently, this contract only transfers gas tokens. So if you're transferring from BSC to Polygon, you will get testnetmatic on Polygon as a result of this action. So DoSwap helper checks that a pool exists. If it does, then it creates a path between two ZRC20 tokens. If a pool does not exist, then it creates a path swapping from source ZRC to Zeta and then to target ZRC. And since all pools, all ZRC20 tokens have a pool with Zeta token, this works. So you then approve, and you're using Uniswap router to swap tokens. So the functionality for all of this is implemented above. So we can do withdrawal. And yeah, after you swap, you want to withdraw the tokens back to the destination chain. And you can see the functionality here. It's pretty much the same as in the withdraw tutorial. So it's using ZRC20 withdraw function to withdraw tokens. So if you want to learn more about ZRC20, you can go to the docs in the developer section, concepts. You can read more about what ZRC20 is and what features it has. So in the current testnet, we need to apply a temporary workaround. Don't pay attention to this. It will be removed once the next testnet is live. So yeah, just when you do operations like this, just for now, multiply by 2, otherwise the transaction is not going to go through. So, okay, so how does this work from a script, from a task? So the deploy task is very simple. It just deploys the contract using a system contract address. It is hard-coded right now here. We're in the process of switching to a slightly different system for storing these addresses, but you can always get the value from the reference here, or actually API also contains system contract only. If you go to this address, API Athens to zetachain.com, you can get system address from here programmatically. So from a script, you can query it. So if you go to this, well, you can basically see the same system contract, C67. Here it is. So other values will be available on the next testnet on Athens 3 as well. So all of them will be exposed through either directly on the chain's API or through the system contract. And you will be able to import these values from NPM as well. But for now, they're hard-coded temporarily. So deploy is fairly straightforward. And let's look at the swap. So again, currently, these values are hard-coded here, but they will be imported from NPM in the next iteration. You can, by the way, you can find all these values in the Zetachain monorepo. Here it is. So I just copied it because it's not published on NPM yet. So these addresses are basically addresses of ZRC20 token. So what we're doing to execute the swap is we're first preparing data. So preparing data just accepts a contract and a set of parameters. In this example, it just needs destination token address recipient and minimal output. And then it just formats and concatenates them so they can be submitted as a value of a transaction. We then get TSS address using ZetaChain's helper method getAddress. So depending on the network that you're broadcasting to, we're choosing the right TSS address, and then we're just sending a transaction to a specific TSS address that we got here with a value that will get swapped and data that contains these values. So these values, again, get passed to the contract here, right? So all the data that you prepare here will be passed to the contract on cross-chain call, if it's called successfully, that is, of course. So now we can just deploy, try it out. So deploy. I'm in the low project. Let's go to swap. Okay, it has been deployed. And we can now use the swap functionality to swap the tokens. So, but before we do that, let's check our balances just to see the change in values. Okay, so let's send BSC tokens. You can type help to show all the flags. So this task has 4 flags, so it's helpful to see them. So amount we'll send to. Contract, we'll use the contract address that we just deployed. Destination. So first of all, let's use the network standard hard hat network flag to specify from which network we're going to swap. So we're going to select BSC testnet. And destination is, let's say, Polygon testnet. And recipient, we can just skip that value because the swap task just defaults to the signer. So we can send it to someone else, but we'll send it to ourselves. So let's broadcast this transaction. Okay, so it has been broadcasted successfully. Let's try opening it on Explorer. Probably going to take some time for it to be processed. You can also query by transaction ID, transaction hash, I mean. Okay, so we can see that it has been successfully broadcasted to BSC. You can also look it up on BSC Explorer. And it was sent to ZetaChain first, where it will be swapped. And we can see related cross-chain transactions. So this transaction is an outbound transaction to send tokens from ZetaChain to Polygon. So we're sending from BSC to ZetaChain and from ZetaChain to Polygon. takes a while to process because there are many transactions right now in queue. You can also query the balances, for example, and see if it has been reflected on Polygon already. No, it hasn't. Well, we can see that 2 tokens were deducted from BSC. We had 85, and then we have 83. Okay, we can wait for it to be processed. In the meantime, let's see what else is there. So this should cover the swap functionality. I mean, it's not necessarily swap functionality, it's just an example of how to build Omnichain contracts, right? In this example, it just does the swap, but yeah, you can imagine that in the body of the contract, you can do whatever you want. So this is very useful because you can build applications that let users manage assets on all the connected chains without wrapping, without bridges, and it's all done in a single contract. So this is cool, but we also have a different way of building dApps. So if you go to developers, these tutorials are focused on Omnichain smart contracts, but there is also cross-chain messaging. You can read more about it here. And it's a different way of building dApps. So with Omnichain contracts, you write a contract, deploy it on Zeta Chain, and it can manage assets from all the connected chains. With cross-chain messaging, it's a more traditional way of doing cross-chain dApp development, where you can deploy the same contract to several chains, and with Zeta Chain, you can send messages from one chain to another. So right now, there are examples, but I invite you to go to the example contracts repo. It hasn't been finalized yet, so if you go to pull requests, there is a cross-chain messaging message tutorial here, and you can already check it out. It's just an updated version with deploy scripts written, and everything's working. So let's open it in a text editor. So it's PR number 1. Okay, so you should see a message directory, and let's go over the contract. So with Omnichain contracts, you needed to implement on cross-chain call function. With cross-chain messaging, you're using a slightly different set of APIs. So in this example, we're just sending a hello world message from one chain to another, right? So we're implementing send hello world, setting gas, all these things, right? And we use the connector, so you can read more about the connector in the docs here. So you can read more about the connector API, and but basically to implement cross-chain messaging with Zeta Chain, you can call the connector send function to send messages, and you implement 2 functions on Zeta message when a message is received. and on Zeta revert when you need to revert a message. So fairly straightforward. The only thing in this example you need to pass is destination chain ID. So the chain IDs are the same. So Gurley is 5, BC 97, and so on. Right. So let's say we deployed this contract to Polygon and BSC again to send the message from Polygon to BSC. I mean, you would deploy this contract to both chains, right? And you would send a hello world transaction to Polygon with a destination of BSC, and it will send a message from Polygon to BSC. So this is the only thing you need to implement to send a message. This is a simple plain text message, but you can, of course, use that and extend and make it more complex, more interesting. When this message is returned, the only thing we're doing is emitting a hello world event. And here's implementation on revert. So there are some tricky bits to this. So for example, when you need to deploy, like there's a difference in deployment process between Omnichain contracts and message passing, because with Omnichain contracts, you deploy it to a single chain, to Zeta chain, right? You deploy it once and that's it. That's why the deploy scripts, for example, for swap is super simple, right? You just deploy the contract to a single chain. With cross-chain messaging is a bit different. We need to deploy the same contract to 2 or more chains for it to make sense, right? Because you need to send messages from one chain to another. So the deploy script looks a bit different, but it's still very easy to understand, right? So we have just two main steps. First is we deploy contracts to all the chains. So in this task, we have a networks argument, networks flag, and it accepts a list of chains. So for example, if you were to deploy it, you would run npx hardhat. Let's switch to message. So you would type npx hardhat deploy, and you would specify not network, but networks. It's a non-standard flag because we list all the chains comma separated. So BSC testnet and Polygon. This is the arguments that this deploy script accepts. It needs one or, well, it needs 2 or more actually networks, right? And when you pass these values, they're sent to the networks. We split them by comma, and then we deploy the contract to all the chains, right? Once that's done, we store addresses in a contracts object. And what we need to do next is we need to set interactors. So what this does is if we go to the implementation, we're calling set interactor by chain ID. So for a contract deployed to Polygon, we need to provide the mapping between a chain ID and the address of the corresponding contract on BSC. So on Polygon, we're setting chain ID 97, which is BSC, and counterparty contract, which we just deployed on BSC, right? So deploying 2 contracts, and in each contract, we need to provide the mapping between the counterparty chain and the counterparty contract on that chain. And of course, you can deploy to 3 chains, for example, and then you will need to set 2 mappings in all contracts, and this deploy script does exactly that. So if you were to run it, you would see something like this. So you successfully deployed contract on BSC, and you get the address. Deployed on Gurley, you get the address, and then the script will automatically set interactors on all chains. So once that's done, you will be able to use the message task, and this is very simple. You just provide a destination chain ID. So for a contract deployed to Gurley, we would run message network Gurley and destination BSC testnet. So it will take the chain ID and actually send the message from one blockchain to another. So it takes long to show this because it takes time for it to be deployed and then used, but I already have one that I executed recently, so we can check it out. Let's see. Okay, yeah. So this is a contract deployed. It's the same contract, and we're sending a hello world from Polygon to BSC, just exactly as I showed in the editor. If you click on it, first page. So you'll see sender from Polygon to BSC, and if you click on address, you can see that we set interactors. Actually, I set interactors twice, but it's unnecessary. So because you don't need to set the interactor for the same chain that you're on. But if you go to events, you can see hello world event, which is exactly what this contract is supposed to do. So when it receives a message from another chain, it should print hello world, emit a hello world event. So even though it's still in a PR, you can check it out and use this as an example of how to do message passing. And it's a very simple example, but I've updated it so it works out of the box. If it doesn't for some reason, please let me know, create an issue, and I will look into it. But very soon it will be merged. And yeah, you can use this as an example. If you want more advanced examples, we have currently in the Zeta chain repo. We're moving it out from this repo, but still they're here. Example contracts. So we have an NFT example with cross-chain warriors and the message example, which is deprecated, and the counter. All simple examples. They're all going to eventually move to the docs, but yeah, if you want a more advanced example currently, you can find them in the Zeta chain model repo. So let's see if our transaction, okay, it looks like we now have the transaction succeeded. If you go here, if you remember, we had around 960 or something, and 4 minutes ago, we got an incoming transaction of 4084 thematic that we sent from BSC. So to BSC is 80 thematic. So I encourage you to use Zetascan. It's very helpful because for all these cross-chain transactions, it's very easy to get them confused. And like here, you can directly see an inbound process transaction from one chain to another, and you can also see related cross-chain transactions, so you can follow the breadcrumbs and kind of see the whole picture. So yeah, I think that's pretty much it. I wanted to cover the kind of going back where we covered the verify hard hat task, which is useful for verifying contract on Zetascan. You can also use Zetascan directly to verify it by dragging and dropping a metadata JSON. We looked into how swap works. So it's a very simple way of building dApps where you just implement a single function that has APIs to withdraw tokens on any connected chain. We used Uniswap for that. Of course, you can deploy your own AMM on Zeta chain and use that instead. It does have to have all the necessary pools, but like for these purposes, using the Uniswap directly on Zeta chain is preferable, but you can call your own contracts from here. And we also looked into cross-chain messaging with a simple hello world, but the pattern is the same. So you implement on Zeta message, on revert, and then you're using connectors, send API. All of this can be found in documentation, so please check it out, learn more about all of this. And yeah, thank you so much for following along. If you have questions, you can find the channel on DoraHack's server. As soon as Discord opens, you can ask questions here, or even on Zeta Chain's Discord as well. So thank you so much.
Yeah, sounds great. Thank you very much, Dennis, for this very detailed, but very useful workshop again. I believe this is super helpful for all of the audience, all of the developers who are watching this and trying to build something on top of the data chain technology. So yeah, just like Dennis mentioned, if you guys have any questions in terms of the technology, please feel free to join that chain's Discord channels and ask any questions that you guys might have there. And during the hackathon, if you find any problem about project submissions, about difficulties of how to use the platform, please feel free to join DoraHacks communities, and we will have our ops team and product team to support you there. Yeah, so just like I mentioned at the very beginning, the hackathon have already kicked off. The official submission channels is live on the DoraHacks platform. So please feel free to join anytime during right now until the end of the June. This is a 55 days hackathon. So definitely don't wait until the last minute to submit your project. Yeah, we're very looking forward to meet any of the talents and brilliant teams that potentially can be emerged through this hackathon. And very exciting about these opportunities to work with data chains. Yeah, so I think that's it. Thanks again, Dennis, for joining us, and thanks for everyone who joined us for this workshops. And very hope you guys have a great day, and looking forward to see you guys soon.